Hello all, my name is Shan Singh and welcome to my YouTube channel. So this is the second tutorial of the statistics playlist where we will learn what are the various types of the statistics which are exactly descriptive and inferential statistics. So let's go ahead. See, in the last session very first we have learned what the statistics is, which is all about a three step. You have to collect data, you have to organize data, because while doing data collection you will end up getting raw data. That's why you have to organize the data, and then you can basically analyze the data and have the insights from data itself, right? Now let's learn what are the various types of statistics. See, in general, statistics is broadly classified into two categories. The very first is a descriptive statistics and the second is a inferential statistics. See, in inferential statistics, okay, so very first let's learn what the descriptive statistics is. See, descriptive statistics, the word descriptive, it itself says a description, right? It says a description, right? It means it is actually trying to summarize our data pretty well, right? So descriptive statistics, it is basically used in order to describe or in order to summarize our data pretty well, right? In order to summarize our data pretty well. See, while summarizing our data, you can think of using techniques like mean, median. You can think of using something known as a variance, standard deviation, some concepts like percentiles. You can also think of using some plots, right, like box plot and various plots that we will learn in our upcoming sessions. So let's consider some basic example just to understand what the descriptive statistics actually is, right? See, if you have the COVID-19 data, you can easily understand what could be the pattern of increases COVID-19 cases. Let's say on y-axis we have the COVID-19 cases, right? And on x-axis all we have is the date. So imagine this is the curve that I have extracted from the data itself, right? So I can say that COVID-19 cases actually increases in a exponential fashion. Let's consider one more example. Let's say if I have to ask how many centuries Virat Kohli have scored, right? So if you have your cricket data, right? If you have your cricket data, all you have to do is you have to count how many times you have scored 100 or more runs. Okay, let's consider one more simple example. So imagine I am losing sales of my watches, right? Okay, so let's say I am a shopkeeper and I am losing sales of my watches. Then if I can ask questions like where I am losing my sales and let's say when I am losing my sales. So if I can ask or if I am able to answer both these questions, that's where descriptive statistics comes into picture, right? That's where the descriptive statistics came into existence. So all it means is that we can think of using descriptive statistics, right, just to understand our past data, right? It means descriptive statistics is basically used in order to understand what has happened inside your data, right? What has happened inside your data. Okay, so let's understand what exactly is a inferential statistics. Let's understand that. See, okay, just to understand what the inferential statistics is, let's consider a simple task. So imagine we have to compute what is the average watch time of the YouTube users in India, or let's say Netflix users in India, right? Let's say I have to compute that. So if I have to compute what is the average watch time of YouTube users in India, all we need is data. See, YouTube has around more than 500 million users in India, right? It has roughly around 500 million users in India. So it means I have to collect the watch time data, right? It means I have to collect the watch time data for all the 500 million users, but it will be quite expensive, and it will be quite time consuming as well, just to collect this huge chunk of data, right? And it will be so impractical, because we have to store this data, we have to pre-process this data, and then we have to analyze this data so that we are able to answer that what is the average watch time of YouTube users in India. So imagine I have this whole 500 million users of India, right? So imagine these are all the users, and from this, let's say I have extracted some sample, right? Let's say sample size is 10,000, or let's say 100K. So from the sample we have, all we have to do is we have to compute what exactly is the average watch time of the YouTube users, right? And just to answer this question, you have to basically consider your sample. It means in inferential statistics, all we are trying to do is we are just trying to understand the trend of the population, right, on the basis of the sample that I have selected from the data itself. So let me explain, or let me write down a simple definition of what the inferential statistics is. So it means you are trying to make the inferences or the estimations, right? You can term it as a conclusions, right? It could have many terms, but you are trying to make the inferences about the larger population, right? About a larger population from the sample you have, from the sample of the data you have, you can say. That's what the inferential statistics is. So imagine you have a real world problem. Let's try to understand from context of a real world problem. So imagine you have a real world problem, right? And let's say the problem is as simple as that. I have to compute the average view of let's say a particular YouTube channel, right? And let's say this particular YouTube channel have some certain amount of video. Let's say it has 100 videos. Let's say some video V1, right? Okay, so I have to basically compute the average views of a YouTube channel. So let's say video V1 have some number of views. Let's say it has a 1100 views, and let's say a video 2 have something around 2100 views. Some video 3 on that channel has around 10,000 views, and so on and so forth. Some video 100 have some roughly around, let's say, 1 million views. So it means this is basically my data. Now if I will ask you, this problem can be solved whether using inferential statistics, or this is a case of a descriptive statistics. So hey, can you do that, and in what scenario you have to use what type of statistics? So let's try to understand that. So you can think of using both the statistics. If you're using your descriptive statistic just to solve the task you have, right? So all you have to do is you have to basically consider all your videos, or you can say you have to consider all data. So it means all we have to do is we have the basically 100 videos data. We will say we will compute the views of all the average view of all the 100 videos by using this simple formula, right? And when we use the inferential statistics, all we say is we will say we have to basically consider some sample of the data, right? So let's say we have the total 100 videos, right? Okay, while extracting a sample, we have to actually extract in a random way. It means, let's say we can think of extracting some sample size of 10 or 15, right? So let's say I have some 10 videos. So I can say that V4, let's say some randomly extracted videos, right? These are the randomly extracted videos. So I will just divide it by 10 so that we will actually have a average value, right? So it means all we are trying to do is we are trying to, using sample, we are trying to make conclusions for the whole population we have. So let's talk about a simple tips and trick just to remember descriptive and the inferential statistic. See, if you're talking about, let's say, hey, I'm going to use all my data to solve any challenge, it means I'm just using a descriptive statistics over there, right? But when you use some sample of data, right, when you use some sample just to make some estimations about your whole population, that's where you have to actually use something known as inferential statistics, right? See, even machine learning uses inferential statistics under the hood, right? Even it is using it uses inferential statistics extensively under the hood. See, machine learning is not about inferential statistics. It also uses probability. It uses some calculus theory. It uses something known as linear algebra. It uses something known as vector 3D. So typically machine learning is all about these 5 core areas. See, in machine learning, what we often do is, very first we have to actually train our model, right? We have to actually train our machine learning model on the basis of the data. So we usually train our model on sample data. Once my model got trained, then we have to actually do a prediction on top of some new data, right? On top of some unseen data. And it means you can say that that's what the use of the inferential statistic, because using a sample of data, we are actually trying to make conclusions, right, or the prediction about some larger data or about some unseen data, right? So that's all about the inferential and the descriptive statistics. For those of you who have any doubt, please share in the comment section. I will love to answer that. So that's all about. Take care, God bless you, and bye bye.